Hello and welcome to 1-2, Measuring and Constructing Segments. So we're going to be talking about measuring some different segments and constructing them. So at the top here, you can see that we have a ruler and on it has centimeters and inches. So the ruler postulate says that any point on a line can be matched 1-to-1 with the real numbers. So if we're talking about 1, 1.1, 1.2, 1 3/8, 5 7/8, those are all real numbers. Notice when we talk about them on a ruler postulate, they are all going to be positive. So the real number that corresponds to a point is the coordinate of the point. So if we have a segment, we can measure finite distances. So a distance, what is a distance? It is the length of something, and it is always the absolute value of the difference of the coordinates. Absolute value of the difference of the coordinates. So if you look at this number line here, we have a dot at -4.5 and another one at a +2.5. So some of you can just look at that distance and you start, and we know that 0, 1, 2, 3, 4, we know we're going to have 0 be right here. So if you count from -4.5 to 0, we know that this distance is 4.5. And then if we do this jump here from 0 to 2.5, we can add those together and we get 4, 5, 6, 7. So we know that from this dot to this dot is going to be 7 units. Okay, so now if we use this absolute value difference part, there's two ways we can do it. So one way, putting in the absolute value, we start at -4.5, and the difference means we're going to subtract the other number, which is 2.5. So now if we take -4.5 minus 2.5, we have the absolute value of -7, and the absolute value of -7 is 7. Now another way that we could do that, still doing the absolute value, and then let's start at 2.5, and we are going to subtract, because it says it is the difference. We're going to go 2.5 minus, and our other number is -4.5. So 2.5 minus a negative is really saying 2.5 plus 4.5, and we get the absolute value of 7, and the absolute value of 7 is 7 units. So you can really do this any one of those three ways. Just remember that when you're finding distance, it is always going to be a positive value. All right, congruent segments. So a lot of times in geometry, we interchange the words between equal to and congruence. So if we say A is equal to B, we're going to put an equal sign in there. But sometimes we're talking about segment AB is congruent to segment CD. So in this particular diagram here, this symbol right here with an equal sign with that tilde mark above it means same length. That is your congruent symbol. So anytime you see the equal sign with the tilde above it, that means congruent to. So if you look at here, AB and CD, how do we know that they are congruent or equal in length? Well, they both have that red tick mark marked in here. So we have a tick mark here and a tick mark here. So that means that they are equal lengths. So the length of AB is equal to the length of CD. Well, we can also say segment AB. So see with that mark above it, we're talking about segment AB being congruent to segment CD. And we're going to use that congruent mark in there. All right, what does between mean in geometry? So when you guys are sitting here in your desks or in your classroom, we talk about things being between, but in geometry, it means something specific. And when you were talking about collinear points, points that are on the same line, you can say that one is between the other two. So if you look at this first one, we have collinear points, A, B, and C. And B is between A and C. Whereas if you look at the second line, we've got D, E, and F, and E is not collinear with D and F, so we do not say that it is between. To be between, we have to be talking about collinear. All right, the main big thing from today that we're going to be using is the segment addition postulate. So if you look down here on this line that we can barely see here, let's see if I can scoot it up a little bit. Segment addition postulate. You can see that we have a line A, B, and C, but we do have a segment. A, C is a segment, and B is between A and C. The segment addition postulate says we can take the portion AB plus the portion BC, and then if we add those two lengths together, it has to give you the total length of AC. So this is called the segment addition postulate. So if I tell you AC is 10, and now I tell you AB is 2, you would be able to have the knowledge to be able to find out what the length of BC is. So BC here is going to be 10 less 2, and so we're going to end up with BC being 8. Now that's great when it's all numbers, but sometimes we're going to give you some letters in here. So here we've got a map. We've got St. Louis, we've got Tulsa, and we've got Lubbock. Okay, and it's telling you that from L to S is a total of 738 miles. Now from Lubbock to Tulsa, they tell it's 377 miles. How far is it from Tulsa to St. Louis? And by using our segment addition, we can tell that LT plus TS must be equal to LS. And now we can substitute in LT is 377. We don't know what TS is, but we know the whole thing is 738. So if we subtract 377 from both sides here, we can find out that this distance is 361 miles, I believe. So TS, the distance from Tulsa to St. Louis, is going to be 361 miles. So that is using segment addition. All right, the last problem that we have for today's notes is going to be something like this, where we have a segment A, B, and C, and we want to know what the length of BC is. Well, with the segment addition property, we know that AB plus BC must be equal to AC. And just like I did in the last problem, we can substitute equal values in place. Now, it might not just be numbers here, but we can substitute values. So we know AB is 13x minus 1. And we know that BC is 7x plus 66. So if we add that to it and get a mathematical algebraic expression here, and now they tell us AC, which is going to be our whole length, is 12x plus 185. So it turns into, from segment addition, into an algebraic expression. And so this is last year's stuff, combining like terms. So on the same side, we have 13x and 7x. So we have 20x. And we can combine the like term of -1 plus 66 and get 65. And then there's nothing to combine over here, so we just have 12x plus 185. Okay, now I have to get my like terms together across sides here. So I'm going to subtract 12x from both sides. And at the same time, I'm going to subtract 65 from both sides. So what do we have? 20x minus 12x is 8x. And 185 less 65 is 120. And now that says 8 times x. So what I'm going to do is divide both sides by 8. So when I take 120 and divide by 8, I get x is equal to 15. Now, a lot of times in geometry, you have to really pay attention to what they're actually asking for. Last year, you guys were used to stopping when it says x equals 15 and you were done. But notice what the question is here. It says, what is the length of BC? Well, the length of BC is 12x plus 185. Well, we just found out that x is 15. So we're going to replace that x with 15. And then we're going to add 185 to that. And our total, I believe, comes out to be 365. And there's no label on here, so we're just going to say units. All right, so segment addition using your ruler postulate, and make sure that when you do the distance, it's always a positive. So using the absolute value of the difference of the two numbers. Okay, good luck on your homework.